Hello everyone, welcome back to Ampnics. In this video, we will walk you through designing a 4-channel home automation PCB in KiCAD from scratch. Whether you are an electronics enthusiast or professional, this tutorial will help you through to design a smart home application home automation PCB. So let's get started. Open KiCAD, click on File, New Project. Okay, I will write the name for this project. So we are going to make a 4-channel home automation PCB. So I will write Arba Amp version 0.1. Okay, okay. So you will get here two files, Arba Amp version 1. KiCAD schematic and KiCAD underscore PCB. So we will click here. Alright. Now our sheet is available. So in this sheet we will make our schematic. Those who are not aware about like how to use KiCAD and how to make the schematics, I have mentioned a link in the description. You can check that, a playlist named how to KiCAD. So in that KiCAD videos I explained these problems within 2 or 3 minutes of tutorial. You can follow that if you stuck somewhere. Okay, so as of now I will cut this and this. Alright, then I'll go into file, then I'll go on page setting, then I'll issue the date. This is version 1 point. Okay, I will write version 1 point, title Arba Amp version 1, or I will write Arba Amp automation company. We will write our organization name here, Ampnics, designed by India Marmania. Okay, hit the OK button. Alright, so all the details is reflecting here. Okay, now we will add our components, then we will wire it up. Okay, so for adding component, use shortcut key A, or you can press here. Okay, so I will use shortcut key A. Our schematic design is completed. Now what I can do to make this schematic more readable, we can add boxes, or we can like we can divide the sections so that it can be more readable. Okay, so how can you do that? You have to go in place and draw lines, or you can press the shortcut key I. Okay, so I will double click here and escape. Okay, so from up to down I'll make a line. Just double click. Okay, press escape. I want to change the style of this line, so for changing the style, first select the line, then press E, then in style I will make it dashed. Okay, then I'll make more divisions. Okay, so just press I. Alright, now all the divisions are done. So if we focus on our schematic, so mainly we have few divisions. Okay, we have a AC to DC power supply, which is responsible for taking the 220-volt AC in input, which is phase and neutral. Okay, then that 220 volt is converting into 5-volt DC. Then further, that 5 volt DC is converting into 3.3 volt with the help of this LDO. Okay, why it is necessary? Because our MCU, this ESP32 room 32, works on 3.3 volt. So for that reason we have to convert this 5 volt into 3.3 volt, and our we are using the relay which works on 5 volt. So with the help of 5 volt we will switch our relay. Okay, but for providing the signal to our relay driver, we need 3.3 volt, which is coming from this MCU. Okay, so the funda is pretty straightforward. Basically we are converting 220 volt AC into 5 volt DC, then 5 volt DC into 3.3 volt DC. Okay, so 5 volt is for turning on the relay and 3.3 volt is for providing the energy into the microcontroller. Okay, we have now we have another section which is programmer debugger. Okay, it is responsible for programming our this board, this whole circuit. Okay, so for this we are using CH340C. Basically it is bridging between USB to UART. Okay, then further we have your terminal block, which where we can connect the external push button or rocker switch or capacitive touch sensor. Whatever you want to attach here you can do that. And along with that we have added few pull-up resistors as well, so that we can avoid the floating values. Okay, if you have any problem or any doubts you can comment it below, or you can join our community section. The link is in the description. You can join our WhatsApp community as well, where we discuss about these things regularly. Okay, so this is our whole schematic. It is very simple. I don't think so there's a um, any complexity, but yeah, if you face any difficulties feel free to ask. There's one more important thing in our schematic, which is a 0 ohm resistor. Okay, this 0 ohm resistor. So with the help of this 0 ohm resistor you can isolate the whole system. Suppose if you have any problem in your circuit and you want to debug it, so on the hardware you can debug it using these 0 ohm resistor. It may be possible that you are not getting at this point, but you will get it when we will design our layout. So no problem. Just see, we have added three 0 ohm resistors. One is here for ESP, and one is for relay driver, and one is for LDU. So if you remove this resistor, so there will be no power in this circuit in our ESP module. Okay, so the significance of this 0 ohm resistor is very useful. So now we will go for the footprint assignment because our schematic is completed. So for assigning the footprint you have to click here. So few of the component already have the footprint, or few of don't have the footprint, so we have to assign the footprint for it. Okay, so what I will do here, you can select it by pressing the control button. So point 1. Okay, so this point 1, point 1, point 1. Okay, all these point 1 capacitor, point 1 microfarad. So I will choose the 03. Okay, 03 0603. Okay, double click on it, and for 10 microfarad press control button on keyboard and then click it, left click on the mouse. Okay, so for this we will go for 1206. Okay, for 10 nanofarad. Then we have our LED. So for LED we can select all together. If you want to select all together, just click first one and the last one by pressing the shift button on your keyboard. Sorry, I have to first select this and this. Okay, now we have to go in LED LED SMD. Okay, then we will choose the size 0603. Okay, then we have a terminal block. Okay, we have a connector pin, 4-pin connector. So this 4-pin connector is extra if you want to add anything in future. Basically, if I show you here in schematic, you can see there is a SD and SCL pin, so you can attach here like any I2C device or like display or any sensor. If you want to use it, you can use. So we will go in connector, connector in header. Okay, and we will select this one. Okay, now we have a resistor. So for resistor, I'm gonna use the same package size for each and every resistor. Resistor SMD, then 0603. Okay, so now our resistor is selected. Now two things are remaining, the relay and the TVS diode. So we will add it manually. Okay, so just select these diodes. Okay, double click here. Then we have our relay. So it is added from external source. If you want to see how to add the external footprint libraries, make sure to check the description. I have added the video for it. So here it is, HF46F. So just double click here. Okay, now each and every footprint is assigned. Now we can go for the PCB design or PCB layout. Just apply save schematic and continue, or you can directly hit the OK button. We will go for the PCB layout. So double click here. Once your PCB layout editor is open, you have to click here, then update PCB. Alright, are all the component is available here. Okay, and unfortunately we have selected a wrong push button, like we required here a different push button here. So I will change it right now. Okay, if you do so, how can you do that? Again, you have to check the assign footprint, and I'll check the button or the push button where it is. Okay, SW push. So I need a separate different type of push button. I need SMD button. Okay, so for that I will use here, I have to select the button switch SMD, and I will use this one. Double click. Now hit OK button, and we can open KiCAD right now, and then we will again click here, then update PCB. Now close. See, our push button is updated. We will start placing our devices in a plane. Okay, so here we will make our outline and all. So we have to make the proper placement of the component so that our PCB should work efficiently. There are few considerations for using decoupling capacitor, for using antenna, for using a power supply in your PCB. So there are few considerations. Okay, so first what I will do, I will place proper components. Okay, once my placement is done, how can you do that? Basically you have to just click here. Okay, and then press the left button on your mouse and place it anywhere. wherever you want in this sheet. Okay, so you can move it here to there. So what I will do, I will make proper placement of each and every component. In this way we placed our component, and there was few consideration which I was talking here. So we have our antenna here, which is out zone. So if you see, like we didn't kept anything here, like we didn't kept any component here, because this is something which will be utilized by the antenna, so we cannot place anything here, not even the copper core area. Okay, those who don't know about copper core area, they just have to follow it what right now. Okay, then we have some decoupling capacitors also. So the function of decoupling capacitor is quite simple. Basically you have to remove the noise which is coming inside of your digital ICs. Okay, so we have added few decoupling capacitor here for ESP, then we have few decoupling capacitor for here for a relay driver, then we added few capacitors for smoothing the current also. Okay, so these are the key factors like which tells about like where to keep our components in our circuit. So placing the component in your circuit takes a time, like how it is totally upon you, like the more time you spend on it, the more beautiful or the more efficient PCB you get. Okay, now we will make the board outline. First select the edge cut layer. Okay, select the edge cut layer, then we will draw a rectangle here. We are going to design a round rectangular outline for this board. So first we will make a rectangular shape for taking the reference. Okay, we will take the reference from this terminal block. All right, all right, so we put a rectangle here. Now we will make the arc. Okay, so for drawing the arc we will select the arc tool from here, and we will draw a arc. So make sure to check the theta value. Okay, so the theta value is about 180 degree from here, and we will make this 90 degree from here. Okay, you can draw it manually on each and every corner, but what I'm gonna do, I'm gonna just duplicate this. Okay, I'm gonna duplicate this and I will use. All right, now we can delete the existing rectangular shape. Okay, use this draw line tool. Okay, connect this line here to here, and here, here. Make sure to check it properly, like it is connected or not, it is properly connected or not. Otherwise later on it will create DRC issues, so we have to keep in our mind earlier only. Okay, to select the edge cut layer, then we have to go in draw circle. Okay, then we will draw a circle about, I'll keep it to 1.5 mm. Okay, press escape, and I have to do it on every corner of RPCB. So what I can do, I can make the duplicate of this. Okay, control plus D, control plus D, and control plus D. Okay, Now we will go for the designing of layout or designing the track in our PCB. So this is two layer PCB, so we will utilize front copper layer and back copper layer. Okay, so select the back copper layer and make the tracks. Our layout is completed. There's only one net which is not connected anywhere, like, and you can see in our whole PCB we didn't connected the ground via tracks. So why so? Because we are going to use the copper fill area, okay, or we can say copper port. Okay, so how to do that? Just click here and we will make a copper pore area. Make sure to select the front copper layer or back copper layer or bottom copper layer. Okay, just select that. You will see this pop up. We'll select both the layer, then we will select the net ground. Now press the shortcut key B. All right, now we can see we poured the copper area on our PC. After pouring the copper on PCB, what you have to inspect it manually, like is there any net which is not connected somewhere, so you can verify it. Okay, all right, there's a one net which is not connected, so we can connect it via the help of this. And sometimes you can see like there is no field zone here, so we can do that manually. It happens, like you can see there's no poured copper here, so you can do it like again. So in this way you can add wherever you want. Okay, we have to add few text. So for adding text you have to select the front silk screen. Okay, you have to select this layer, and then we have to go here in text or draw text. You have to click here, just click here, and we will put the text what we want to put it here. I will put my text here. And I will make the text bold, and I won't make it the knockout is enough. We can change the size of the text as well. We'll keep it 1.5. Yes, so this is visible and big also. We'll add few more text. I will add here make area. Okay, and I will make this out bold. Okay, I will make the duplicate of this text. So for duplicating this, control plus D. Okay, I will keep it here. What if you want to put this text on bottom side? This is on front side, but what if you want to keep this text on bottom side? You have to click this. Okay, you have to click this, right click, and then just change side or flip. Okay, and then move it here, and we will add a few more text here, or we'll arrange it, and we will put the name, date, and we will make this one. Okay, and I will move it. All right, perfect. Our whole PCB is completed. If I turn on the 3D viewer, so you can see our PCB is quite fine, and I love the placement of component. You can see each and everything is perfectly aligned. Whenever you design the PCB, make sure to place the components rightly, because it improves the aesthetic of your PCBs. And make sure to add few text and like credential, whatever you want to do. You can do some creative stuff on your PC also, and you can mention the date like I did. Can mention your name or whatever you want to mention. You can do it. You have full freedom for that. And I have make some custom cutouts as well. You can see like there's an antenna, so what I did, I cut the this portion. So in this way you can also do it, and you can make your PC next level. Okay, so after all, like our PCB designing is completed. Now we will export the Gerber file so that we can forward it for fabrication. So for exporting the Gerber file, we have to click on file, then we have to go in fabrication output, and we have to click Gerbers. Okay, first you have to generate the drill files. And whenever you generate the drill file, sometimes you will get some warnings and errors, but you can ignore the warning but not errors. If you find some errors, so make sure to fix it first, then go for the Gerber file. All right. So let's generate drill files, right? Okay. Now we will plot the Gerber. It is done. So if I open the project file in my file manager, so you can see the files associated for Gerber is here. So what you have to do, uh, first we will make a new folder, and we will name this folder as Gerber, GRBR. Okay. And what I will do, I will just select all these files, the files which is associated with the Gerber. Okay, then I will uh, select Control plus X, will cut these files, and Control plus V, paste all these files here. Okay, now Gerber files, the files which are associated with the Gerber are in one folder. Okay, so now we have to zip this file. Okay, compress zip. All right, now this is in zip file. So you have now the Gerber file which you can forward it for fabrication, and there are few manufacturers in all over the world. You can find which manufacturers manufacture in your area, and you just have to forward this Gerber file. They will print this PCB and they will forward to you. That's it for designing a 4-channel home automation PCB in KiCAD. I hope you found this tutorial helpful. If you did, don't forget to like, share, and subscribe to our channel Ampnics for more PCB design and electronic content.